Alright, so welcome back. So for this topic, we are now in Unit 4. Unit 4 is trigonometric functions. So Unit 4, trigonometric functions. And when we think of trigonometry, we think, oh, like triangles. But the key thing we're going to focus on is actually the angle part. And triangles have a lot of useful uses in math because like we use trigonometry to kind of see like the ratios that if you have a set angle, the sides that correspond with those angles will have a nice ratio that is used a lot. We'll see that it applies a lot for kind of oscillating motion for things that repeat, because the trigonometric function is something that repeats, and that repeating value, that repeating property is very helpful. So in this topic, in this lesson, the video, we're going to split it up into much smaller videos. So this one is on radians. So going over what radians are, and also converting between radians and degrees, because we're going to be using radians a lot more. So radians is a unit measurement for angles. So what radians are, let's write this up. It's a unit of angular measurement. And it's similar to let's think back to the activity we did in class, where given a circle, we use a radius to find a lot of properties about it. And one main property that I wanted to find out was actually the circumference. Circumference, and it's found using this formula 2 pi r. Where the circumference of a circle, no matter how big or small, is always 2 pi times the radius. It's always in ratio with the radius. I always need 2 pi of them to go around the whole circle. If I use this circle, if I use this circle, if I use this circle. No matter how big or small the circle is, the whole length around it is always 2 pi radiuses, or roughly 6.3 radiuses. Therefore, we could use this property to actually measure the angle, angular measurement. Because we could always, like kind of, if we have two values like this, like an angle, like this angle, we can always extend it out, draw a little circle around it with the angle center, the edge as a center, with a set radius, and see this measurement. And use that in terms of how many radiuses encapsulate this arc. No matter how big or small the circle is, like if I extend this out more and draw a bigger circle, the amount of radiuses that is captured by the bigger circle and the inner circle, and even a small circle right here, will all be the same amount of radiuses. It won't be the same value, like same length. This arc is much longer than this short one. But the number, in terms of like how many radiuses, it'll be the same. Because it all relates to each circle. So that is what radians are. In terms of how many radiuses are used. And we have one thing that's given to us, where 2 pi is a whole circle. So actually go down and let's make a little circle and let's talk about this. So I'm going to preview the unit circle. So with the circle that we start with, I'm going to start as this is my starting point. And this is 0 degrees. And also, it's also, let's not draw a plus there. It's also 0 radians. Like there's no angle. And if we go all the way around, if I do a first full circle, that's 360 degrees. And that's also it's 2 pi radians. Because it takes 2 pi radiuses to go fully around. This ratio of 360 to 2 pi is what we use to convert between radians and degrees. So let's actually find a simple ratio. The simple ratio is actually right here. If I cut it in half, because they're both even values, I could divide by 2. So instead, half a circle will be 180 degrees, but also just pi radians. And I can't really make a small ratio because I don't want to do pi over 2 and 90 degrees. I don't want to make pi smaller and smaller because I want to keep it as precise as possible. So for this unit, we're going to do a lot with just keeping it in terms of pi. So let's talk through the math of converting between radians and degrees. So let's do a little example. Example 90 degrees to radians. How many radians? Like how many radians? And we can see right off the bat, if we keep this in mind, like 90 is just 1/2 of 180. So therefore radians must be 1/2 of pi. And that I want to use an example that we could see this and actually know what the answer should be. So the answer should be pi over 2 radians. But let's find some math way to go from 90 to pi over 2 without, because you'll be asked to be like, oh, what is 54 degrees? I don't, like, it's much harder to see the ratio. But the ratios are what we want. So the process is actually how many semicircles for going both forwards and backwards, like how many semicircles like is in the initial value, is in the initial value. And we'll clean this up and make more sense later. But like it's more concisely, but I want to say it in a way that is kind of easy to understand at this moment. So for 90 degrees, how many semicircles does 90 degrees make up? And this, I have 90 degrees, and we do this by just dividing by 180 degrees. Because one semicircle in degrees is 180. So I have 1/2 semicircles. Half a semicircle, that's 90 degrees. And once you have how many semicircles, then be like, we gotta then convert this into the other value. So I know I have this many semicircles in total, and now you know each semicircle is pi. So if I have 1/2 semicircles, I now want to multiply this by pi to get pi over 2. So the process is pretty much you're going from degrees. Let's actually increase this. You go from your unit, we're starting with degrees, to semicircles, to radians. And the thing is, this also works the other way around. It works both ways. So we just need to come up with this ratio. And this process is actually, will always be get the semicircles, so divide by your initial value. You multiply by the semicircles of the other value. So for degrees to radians, you want to multiply by pi over 180 degrees. And from radians to degrees, that didn't go all the way, you want to multiply by 180 degrees over pi. You divide to get the number of semicircles, then you multiply to get the new unit. Divide by semicircles, multiply to get the new unit. So we'll end it off with just we'll just do 2 examples, going one way and going the other. So let's start off with pi over 6. We'll keep it small for this one, and we'll do degrees very big. So pi over 6, 2 degrees. So first off, I want to divide by pi to get the number of semicircles. And so dividing by pi, the pi just gets rid of it. And next up, you want to multiply by 180 degrees. 180 divided by 6 will get me 30 degrees. 30 degrees is pi over 6. And that makes some sense, because pi over 6, it'll make more sense as we do more and more. But if pi is 180, I want just 1/6 of it. So it'll be much smaller. It'll be like around here, and 30 degrees will be around here. I want 1/6 of a semicircle. Now let's do something a bit bigger. Let's do 450 degrees. So we want to divide by 180 to get how many semicircles we have. And you multiply that by pi. So 450 divided by 180 will give me 2.5 and times pi. So the takeaway for this is when we convert, we can memorize the whole process like this. Like this is a conceptual reason. And also you can memorize the formulas. Like I think the ratio is the main thing. And you know that you must cancel out what you have. So they're on opposite sides. You must cancel out what you have. If you have degrees, you must divide by degrees. If you have radians, you must divide by pi. So that's all for today. Thank you for watching.